happens. I'm sorry. I'm only human. And I do multiple things at once. And it's sometimes hard. Okay. So, why won't it let me move the. Hmm. Oh, because I'm on the eraser. Thank you. So you always make sure you are open up over half because a lot of you don't do that and then get really confused when it doesn't work. So is this open over half? Yeah, I'll probably make it right there. Okay, you are going to then do an arc above and below. Or you can do it like this, or you can just do a little arc up here, let go, and then do a little arc over here. Flip over, right? And and then I'm going to go ahead and draw my line through those 2 points. And I have to make it long enough that it will intersect the other perpendicular bisector, right? And this perpendicular, let me select this. Ooh, why is it not letting me? Let me erase this one because I don't like this line. Oh, there it goes. Come on. Why won't it let me erase this line? Uh, I have to learn this how this erases. Okay, so now I'm going to do the line through a chord through these 2 points. You need to make. You put the point. Make sure you are over half from that point, right? And then we are going to go ahead and draw your arc above and below. You move it to the other point and do the same thing above and below. You move this out of the way. You're going to use your nice straight edge to make sure you're accurate. And then, am I accurate? Yes. And where it intersects the other perpendicular bisector, this is the point that you're looking for. That's the center of the circle. So then you put your needle on the center of the circle, which would be that intersection, right about there. Oop, a little bit. You open it up. And I'm running off the side. Hold on a minute. Let me see if I can do this. No, I just ruined it all. And it doesn't have a come. Oh no. Oh no. Oh no. Oh no. I'm just learning this new program. So sorry. Well, I need to move this. Come on, move it. Move it. Okay. There. Okay. Put the needle here. Close it to the point. And I gotta move mine around a little bit to get it to work. Because I'm learning this program. Ah, come. Why won't you let me just open? Right. I want to open. Oh my goodness. Come on. There. I think I'm on it. Yep. And then you should be able to make the circle. It should be landing on all points, but I'm learning this program. Give me grace. Okay. I need to learn this program a little bit better. Okay, so let me clear out everything. Uh-oh. Did it also erase my loaded document? No, it did. I think it erased the loaded document. Goodness gracious. On device. This one. Open. Okay, so we did those two, right? And we're going to the next page. Do the next page. Oh, it's next slide. Okay, that's why it disappeared. Nope. Nope. Huh. Okay, I gotta make this bigger so we can see it. And now, hand drawing. Okay, so how would I find, and it's wanting me to find this X here, which is this length. What is the radius of this circle? 34.6 divided by 2. Because if it's in the middle like this, it's talking about the diameter. So what's 34.6 divided by 2? What is it? 17.3. Now the radius should equal, I'm just going to do a whole different circle. This whole thing here, the whole thing should equal 17.3. But we're trying to find x, and we have from the center to this point. So what would I do? Yes, so 7.3 minus 8.7 will give me this missing piece here, which would be what? 8.6 is equal to x. So what you had to notice is that you have a radius and you had a diameter. To find the length of the total radius, you divide the diameter by 2. And then to find the missing piece of the radius, you just subtract the piece that you have. Right? Good? Yay or nay? Yay? Nay? Kin, do you understand it? Yay. Ting, you good? Good? No? Maybe? No? Okay. What do we know about all radii of a circle? They're the same. Spokes on a bicycle wheel, right? Our radii. Aren't all those little spokes the same? Visualize it. Think about a bicycle and the little spokes. They're all the same measure. So, this is 3 here, right? This is 3 here, because this is also a radius. So what's this going to be? Radius, which is equal to 3. Did I have to do any work? No, we like those type of problems. Right? Do we like those type of problems? Yeah. Okay. It wants us to find x. We have this chord that's 11. We have this piece of this right triangle that's 8.6. 8.6, if it wanted the radius, it would have put it in the middle. If you ever get confused on a test, not knowing what it's referencing, let me know. I will always tell you because I don't want you to get it wrong, right? This here is the 8.6. This here is the 11. How do I find a missing hypotenuse of a right triangle? Yep, a squared plus b squared equals c squared. 8.6 squared plus 11 squared will equal c squared. What is 8.6 squared? 73.96. Rosie, you are one of my favorites because anytime I ask, you always have the answer. And 11 squared is 121, right? Add those two together. 194.96. And what do I do? Square root. Which one is it? Which would round to 14, technically. So you both were correct. And I don't have a unit, so it's just 14. Now, whenever you take the square root of both sides, when you get to Mr. Adam, he's going to say, you should have two answers. But in geometry, I only put one answer. And yeah, you should always have a plus minus. But in geometry, we talk about lengths, right? Well, can a length be negative? No. That's why you don't see me put plus minus. But I'm telling you, when you go to Mr. Adam, if you take that 136, how many answers should you get when you take the square root? Two, a plus and a minus. Thank you. Thank you. Thank you. So you can't say, Miss Dawn never told me that. You'll probably say that anyway, but. And then I'll have to go to Mr. M. Oh, Mr. M, I really did tell him that. Okay. Does everybody see my mashed potatoes? Are you going to try some? It's in there. And I got gravy over here plugged in. You can't put them in the same outlet or I blow a fuse. Okay. Do you like mashed potatoes? Yeah. I used yellow potatoes, so I kept the skins on. It's healthier that way because skins have a lot of. Yes. For breakfast. Just so you can have my mashed potatoes. Yay. Okay. I am known for my mashed potatoes. I have a little secret ingredient in there that makes it really creamy. Okay. So, hmm, how am I going to do this one? This one's 13.5. I agree. So, yes, this is a two-step problem. I need to find this piece. I know the radius total will be 15, right? Paying attention? I see you doing this. Okay, we're going to pay attention. This is 15. This is 15. To get x, whatever this little piece is, I subtract it from 15. So, how do I find this little piece? Okay. So this is A, this would be B, this would be C. So A squared plus B squared equals C squared. I really like this program. I hope, you know what? They get you addicted to one of these programs. It's kind of like a drug dealer. They're like, learn how to use it, right? Isn't it great? And then 5 months later, they'll say, now if you want to keep using it, you got to pay. I don't like that. Okay, so 13, no, this would still be a squared plus 13.5 squared equals 15 squared. What is 13.5 squared? 182.25. And I know this is what, 225? Oh, I don't like that. It doesn't let me go off to the edge. Okay, what do I do with these two numbers? Subtract. Subtract. 42.75 is equal to a squared. You have to take the square root. A is equal to 6.5. We'll keep it to the nearest 10. And I don't have a unit, so we're just going to put, oh, that's not the actual answer. That's A, right? What do I have to do to find x, though? X equals 15 minus 6.5, which would be what, 8.5? 8.5 is equal to x. Woohoo! Okay, over here. Determine if AB is tangent to the circle. How do I determine if it's tangent? Yes. If it's true, then it's tangent. If it's not true, then we'd say, sorry, not tangent, right? So A squared B C. So 11.4 squared plus 15.2 squared. Does it equal 19 squared? It does equal? What is 19 squared? 361? So this equaled 361. So then we put yes. If you do the math, which Obed did, it should work. Okay. Oh, next slide. This is interesting the way it works. And I got, oh, I don't want a new slide. I need to make it bigger. Oh, the bigger is over here. Okay. Oop. Okay. Find the segment length. Thank you. Find the segment length indicated. So they want the radius, correct? Assume that the lines which appear to be tangent are tangent. So this is going to be a two-step problem. You're going to find the diameter, and then you are going to do what? Divide by 2 to find the radius, correct? Okay. It said assume the lines need to be tangent are tangent. The theorem we talked about is that if it's drawn, if the point of tangency is drawn to a radius, this is a right angle. And so again, what do I use? Equals c squared. Sam, do you understand Pythagorean theorem? Okay, that's because that was the week you were gone. So isn't that amazing? I remembered that. It's simply amazing. Okay, whenever you have a right triangle, I'm going to go slow because I'm hoping you'll decide to do that test because it pulls your grade up a lot. Ask Ting, doesn't it pull your grade up when you redo a test? Yeah. Okay, so on a right triangle, the legs that make the triangle are A and B. Your C is always across from the 90 degrees, and it is called the hypotenuse. So this is hypotenuse. I'm just going to abbreviate it. This is leg. This is leg. So if you square the legs and set it equal to the square of the hypotenuse, when you work it all out, you will find the missing side length, which will give me this missing length of this whole diameter right here. Okay? Now, it's been along for thousands of years. The Babylonians were the first to use it. Do you know why I know it was the Babylonians? Because I watched the History Channel. It was the Babylonians because we know that because of some big things that are in Egypt that are triangles. What are those big things? The pyramids. They wouldn't have been able to build those pyramids without knowing the Pythagorean theorem. And that was through the Babylonians. So, just a little bit of trivia pursuit. You like knowing that type of stuff? Yeah, maybe. Oh, okay. And their compass, they used compass work, but you know how they did their compass? Big stick and a rope tied to the stick. One person hold the stick, The other person was on the end with a big rope and in the sand would make their marks and their arcs that way. Can you visualize it? We'll have Peter standing with a big stick, man way over here with the rope, and swinging the rope around. Okay? Make sense? Yes. Oh, do you know if they were 1 degree off, just one, and think about how many times we are 1 degree off, the pyramids, the blocks would not have sit as a pyramid. Just 1 degree off as it started going up, it would have gotten all mismatched and the blocks would not have fit properly. That's why they are called the wonders of the world. Because math is what? Math is beautiful. That's right. Okay. So, right here, going back some, I went off track, but I just love math, so I had to. Sorry. It actually all related. I'm going to put b squared as 4.8 squared equals 8 squared. What's 4.8 times 4.8? What's 8 times 8? So we're going to subtract them. What is it? 40.96. 6. Oh, when you took the square root, you get, and then, 96. 6.4. So it's approximately 6.4 because you probably rounded. Okay, now this is A. That's the length, which is the diameter, right? But you were right. Obed stopped me before I started moving on because he could read my mind. To get radius, I don't know what it is. Yeah. To get radius, what do you do with 6.4? 5 by 2. And you get 3.2. That's your final answer. We learned a lot yesterday. We learned a lot yesterday. Okay. Now this one student, and I'm not picking on anybody because he's not the only one who's done this, and I'm not going to mention names, but thought, like over here, I just divide by 2 and I can find each of these lengths. Is that true or false? No, it's false. We do not know if this point is the midpoint. We have no information saying it could be, but it also could not be. So for these, you're going to have to walk it around to figure out all the missing sides, okay? This one's easy because over here, if this piece is 6.4, what's this piece over here? That one's 6.4. But to find this piece here so I can give this piece, I'm going to have to do some math and walk it around. So this would be 7.8. Uh-oh, it is half, but not always. Because the only reason I know it's half is what's 14.6 minus 7.8. Yeah, and it just discounted what I said. But that doesn't always work, so don't rely on that. So then this over here is? Huh? Oh, this is 6.8? Oh, so it wasn't half. Woo, good. I'm glad it wasn't half. So let me fix that. I I gotta get used to this new. I kind of like it though. I hope it stays free. Okay, 6.8, right? Okay, so it wasn't half. Yay, it wasn't half. So then this is 6.8 here, right? So then what's this over here? 11. And so then what's this over here? 11. Now I have all the sides. Don't double add. Only do the outside. I'm going to do this 11. This 6.4. This 6.4. this 7.8. I don't add here. I was just doing some math to try and figure out what this length is. You do that 14.6 and the 17.8, and that will give you all the perimeters. So you have to add all of those together. So on 11 plus 6.4 plus 6.4 plus 7.8 plus 14.6 plus 17.8. And I started 8. Yeah. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Press enter. And it'd be, did everybody get 64? Dun, dun, dun. Great work. Gonna try and keep it up there. Okay, now this one. This one we're going to use Pythagorean theorem again. And Sam, I'm not going to pick on you. I'm just trying to make sure you learn Pythagorean theorem in hopes that you'll try and do that test, okay? So, where do you think the 90 degree is going to be? Right here, right? Do you see that, Sam? Okay. Because the legs are here, right? And it said whichever appear tangent, this is the tangent line, it has to be right angle. Now, which would be the hypotenuse? Is it the hypotenuse is the longest side, and that is C. That's the most important one to label first. So if I go across from the 90, this whole length, it would be considered C. Now it's the whole length. So what am I going to write C as? X plus 9. Now, what would be A? It doesn't matter, Sam. You can do X or you could do 15. The one that matters is the C. Because A is X, because you just end up adding them together. And B would be 15. Now I'm going to apply my A squared plus B squared equals C squared. A is X, but I'm going to square it. B is 15. I'm going to square it. And then C would be X plus 9 squared. X times X is X squared. What's 15 times 15? 225. And this one, you have to do some algebra. What do you call math friends? Algebros. Ha 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 ha. No, okay. I'm going to multiply these together. X times X is X squared. X times 9, 9X. 9 times X again. And then what's 9 times 9? And so this would be X squared plus 18. Oh, yeah, 18X. It delayed on me, so 18X plus 81. Okay, do you see how you have x squares on both sides? They cancel each other out. If you subtract the x squareds, that gets rid of them. So I have 225 equals 18x plus 81. I subtract 81. I get 144 equals 18x. And then you're going to divide by 18. I don't have enough room there. Divide by 18. What does x equal? X equals 8. There we go. Okay. Do you all have a compass still? Okay. I want everybody to, I'm going to pass out some scratch sheet of paper. Go ahead and, go ahead and scratch. You're going to ask them. Just tear these in half. You can tear in half. Don't share, just tear it in half. Just tear it in half, share. Okay, once you have your paper, draw a nice circle on there. Beautiful circle. All right, just draw a nice circle with your paper once you have your half paper. Beautiful circle. One big circle. Peter, I'm going to pick on you because we're not going to make poor Miss Sandrea crawl on the floor here. Can you unplug the gravy?
Oh, okay.
So,
Anybody
Peter?
here has bags of food? No? All right.
Peter, come over here.
Where?
Unplug over here.
It's for that?
Can you unplug that? Are you bringing everything over?
Right, thank you.
And Sandrea, I have 2 serving utensils in a plastic bag next to the potatoes.
Can you carry that to me? That's to you.
It's plugged in, so unplug it. Make sure you want to make sure you plug it in, and because it'll be cold if not. And Sandrea, grab the plastic bag. Those are the serving. Make sure I get my serving utensils back.
We might not need it because I grabbed a whole bunch now. So I'm gonna leave them here for right now.
Okay. Okay, everybody have their piece of paper? Yeah. Everybody gonna make a pretty, pretty, pretty circle. Yeah. Okay. Okay, everybody have their paper. How come it won't let me move up anymore? No, thank you. Okay, except mine. Now, I want you to take a straight edge. And we are going to make what's called a central angle. Everybody say that word with me. Okay, a central angle is made by 2 radii. We are going to just draw from the center of your circle. Oh, that's not what I want to do right there. I'm just trying to get mine done. And then, doesn't matter where. But it's not letting me draw another one. I don't know why. Let me try this again. Oh. There you go. And you can make it as wide as you want or as narrow as you want. Wider would be a little bit better for what we're going to do. Just a little bit wider. Not like, no, I hope. Let's cross my fingers. Does it have a protractor? Ooh, yay! Oh, it has a protractor. Guess what you need to do? I want you to measure I want you to measure this angle that you just made. OMG. And please write your angle measure on the inside so you don't lose that number. Mine was 120. Try to do this with my mouse, it doesn't look as pretty. Okay, I just want to move you out of the way. Why won't you move? Oh, because I have the eraser on, that's why. I don't know why it erased part of my circle. Do they have undo? Down, scroll up. Oh, there we go. Ah, found my undo. Okay, shh. Trying to teach you how something. It's actually pretty cool. I think it's cool because I think math is beautiful. Are you gonna? You're not gonna let me. Oh, that's because. No, I'm just trying to move this out of the way. Okay, so what's this angle called again? Central angle. So I'm gonna type in there. Central angle. Let me try and make it bigger. Okay, you good? Now, who here watches Star Trek? Anybody? Yeah. Have you ever watched it? You have? No? Nobody here has ever watched Star Trek? Oh, Star Wars, but not Star Trek. Well, okay, well, now what I want you to do is on the opposite side, I just want you to draw a point. Oop, that's, my point was ugly. But just draw a point prettier than mine, please. I'll try redoing this. No, I wanted to, how come it's, let's see if I can erase this. Make your point prettier than mine. I tried undoing it, but it wouldn't do it. Okay, now, does everybody have a point? I want you to now draw from here to the point, from the end of your, and you're going to do this again. Like this, okay? If you ever saw Star Trek, there was a symbol that they had on their emblem. Right? Okay, now I want you to measure that angle. This angle right here. This angle that you just made. I'm going if I want you to measure this angle. The one you just created. It shouldn't be the same. It can't be the same. This one, mine is obtuse and this is acute. There's no way. I think you're using the wrong side. This is mine. Yours may be different. Okay, this is called an inscribed angle. What pattern do you see? What was your measures? Did anybody have some else other than 120? Oh, you had 55 for your central angle? Oh, you had 116 as your central? What? Okay, Obed, you had 116 as your central angle. What was your inscribed angle? Are you sure? That's okay. Relook at it again.
How do we measure inscribed?
Teacher, mine is 90 and I got 90.45.
Hmm? Yours was 90 and you got 45. Yours is good.
Mine is 67 and
155 and 67. That's close. Yeah. 157 is what you said.
teacher. Mine is central is 195. Inscribed is 28.
Yep, yours is good. Okay, what was yours, Ting? Are you sure it's 90? Remeasure that.
I think 90.
140, and what was your central angle? Or your other angle? 140. Relook at it real close. Okay. Yes. There you go. Okay. If you did it accurately, what probably should have happened with the central angle and the inscribed angle? It should be half. Do you all see that? And that's why I'm telling some people relook at their measurements, because if it's not half, they didn't measure it accurately, or they didn't draw it as good as they should have. Right? Naprit, what did you have? Naprit. Which is exactly half. Very nice. Okay? Pull out your notes and we'll start going over the relationships of inscribed central angles and their arc measured. Oh, one other thing to put, because you may want this as reference. We are going to, this is something you can measure if you have my big circle, but okay. I do want to talk about this for a second. So, do you see an arc outside the circle that our central angle intersected? An arc is part of the circle. So the intersecting, let's see, does this have like a highlighter? Shapes, handwriting. I'll just use yellow. So the intersected arc would be this one right here. Intercepted means that to intersect, right? So this is the arc, or they call it subtended. There's different ways of calling it. But basically, and Miss Dawn will use cuts because that's easier to say and students understand it. See the arc that got cut by the central angle? It's part of the circle. It will have the same degree measure as the central angle. Because the central angle is going around like a full circle, the outside is a full circle, so that arc measure will always be the same as the central angle. If this wasn't, let's say this wasn't here, that these two lines weren't here, and all you saw was the inscribed angle and the arc measure, it still will be half of that arc measure because the central angle and the intercepted arc always has the same angle or degree measure. Okay? These two, central angle, intercepted arc, same. Inscribed angle will always be half of either central angle or intercepted arc, or both, right? So the relationship is this is half of these two. Good? Good? Yeah. Okay, so pull out your notes. This is the front in your notes. This is the one we're looking for. It should say central and inscribed angles. Y'all find that? I'm waiting because I don't think everybody has it quite yet. Okay. So during fun day, some classrooms are going to have games. Some classrooms are going to have karaoke. I think karaoke is going to be in 141. My classroom, we're going to make my octagonal star. I'm going to do origami. Okay? Now, it's from 11 to 1, so you could go to different ones. Or if you're going to hang out in karaoke, that's fine. I'd hang out in karaoke too. Okay. So, at 11. Yes. So I'm probably going to keep you through your break because your class is cut by an hour. Students will be able to determine the angle and arc measures of circles using deductive reasoning skills based upon relationships of inscribed angles, central angles, diameter, total sum of angles in a circle equals, I don't know why that says equally, it should say equals 360. Students will use mathematical words to describe angle measures, such as, I know the central measure is 70 degrees. Because its intercepting arc is also 70 degrees. I know the inscribed angle measures 35 degrees because the intercepted arc is 70 degrees. Okay, before we start, we have to talk about naming arcs. There are minor arcs, there are major arcs. Minor arcs, we use 2 letters, and they are usually less than 180 degrees. Major arcs, we use 3 letters, and they are more than 180 degrees. So when you ask me if it says AB and you're looking at a circle, it's not talking about AB this way, it's talking about in between A and B. But if it says ACB, then it's ACB. You see it? Yay. Okay, so let's talk about the angles and the. So it's saying angle 1. So what would be the arc of angle 1? Yes, and look at how I write it. I use a little arc. Oh, I said that, and I didn't put my drawing tool on. I do a little arc. Whee! It's almost like an eyebrow. ZY. Right? Now, here it says major arc for angle 1. It would be the opposite of angle 1. So it would be here's D, here's angle 1, right? So you could name it a couple things. It could be DGE. By the way, it's not F, because F would be angle 1 and angle 2 together. It would be D, let me make that more look like a G, G, E. Because DE is the minor arc, so you have to go all the way around to get to the other arc. Okay. Now you could have also called it arc D, F, E, but the main thing is you had to start D, E, and had to be the front and back, right? You could have said E, F, D also, and that would have been fine. You could have called it also E, F, D, or E, G, D. All of these would be acceptable, right? But that would be your major arc. Minor arc, major arc. Did we make one of these?
No.
We didn't make one of these? Did we make one of these? Everybody made one, right? And hopefully you found that the angle inscribed in the circle is half the central angle that subtends the same arc. So if I give you AC's measure, let's say I said AC is equal to, I don't know, I'm just making up a number here, so don't say that's not accurate. Let me just call this 96, okay? Degrees. What then would be the measure of angle ABC? What would I do to 96 to get this angle? I divide it by 2, which is equal to, what's 96 divided 40? 30. I was going to say that'd be 48. Okay. Because 45 would be 90. 3 more would be 48. Okay, we good? Make sense? Okay. So, over here, it says, so is this arc or is this angle? Arc. So they're wanting you to find KLM, right? And then I know its arc, it's inscribed angle, because the endpoints of that angle are here and here, is 86 degrees. What would I do to 86 to figure out this measure? Not divide, because we're going the opposite. Yeah, 86 times 2. 2 degrees. So the measure of our KLM is equal to 172. Yay or nay? Okay. These are the notes that I handed out. Did you not have the packet of notes? Do you have the packet of notes I gave you at the beginning of the week? Could you show the begin? You don't have this? Okay. So now, diameter due to a circle, by the way? It cuts it exactly in half. So what would each side be if it cuts it exactly in half? What's half of 360? 180. Yeah, 180 would be on each halves, by the way, whenever you have a diameter. But that's not what they were asking. But I thought I'd throw it out. So is this going to be 15 or is this going to be 60? 60. Because remember, this is half of this. So I would have to double it to find arc AB. Arc AB would equal 2 times the measure of angle ACB. So the arc of angle AB is 60 degrees. That's it. Okay, over here. Now it gets a little bit more complicated because you have to use some deductive reasoning skills. Some of you have deductive reasoning skills, some of you have to develop them a little bit more. Oh, yes? Oh, that should be a B. Yeah. Oh, B. There you go. Okay, over here. What should a total circle add up to? 360. So I have to get this arc measure before I can even think about getting what this angle is equal to. So what I would do is I'd take 118 plus 96, 214, and then 360 minus 214, and that is, what was this? So 146 is LK's arc measure. And yes, to get the actual answer, we'd have to divide it by 2. So 146 divided by 2 is equal to 73 degrees. Okay, now over here, if over here we have half, right? We have 180 on this side, 180 on this side. Everybody agree with that?
Yes.
So this is 180. This has to add up to 180. Can I find what this measure is right here? How would I do that? 37 times 2 is what? 74 degrees. So then how would I find this side over here? Yep. 180 minus 74, which would be 106. So arc AC is equal to 106. Actually, the measure degrees. Measure. That's just what it means. Measure of. It's like a little notation for geometry. Makes sense or doesn't make sense? Okay. Hmm. Is this a diameter? No. Any ideas on how to set this one up? We have this, which is talking about this angle right here, right? We have this, which is talking about the arc GF. What's the relationship of angle GHF and arc GF? Yeah, I have to multiply this by 2 and then set it equal to this to find x. So 2 times 9x plus 11 has to equal 20x plus 10. Make sense or doesn't make sense? So this would be 18x plus 22 equals 20x plus 10. I would subtract 18x first. I always deal with the variables first. Some of you do weird things when you have variables on both sides. I don't know why. 2x plus 10 equals 22. Subtract 10. You get 12 equals 2x. What does x equal? X equals 6. And it didn't tell us what to do here. So if you substitute it in, what do I get? What's 9 times 6 plus 11? 54, 64, 65. And what happens if I do that here? 20 times 6 plus 10. That'd be 130. Is this half of this? Yes, so I know I did it correctly, right? Okay. So how would I do this one then? You all do this one at your tables. Well, go ahead and do it. So, so at x equal? Did you get x equals 6? I agree. Yep, x would have to equal 6. Because you would double this and set it equal to this. So you should have had it set up. I'm not going to go through the whole thing because you should be able to do pre-algebra. You had to double 45 to set it equal to this, right? Okay. They start getting more difficult. There's some of them. I'll do these next two, and then I'm going to give you your worksheet. Okay. Who here has babies in the YLCC currently? Okay. You are blessed because you get to leave at 10:50. Plus, you're blessed because I don't have any grandbabies, so I like seeing the little babies. Okay. So, how am I going to figure this thing out? Okay, so 7x minus 8 plus 13x minus 2. No, plus. I like that plus. 2 times 9x plus 14 equals 360. Remember, this is the arc measure. Angle measure. The arc measure, you have to double this to make it equal here. This should have been 2 times 9x plus 14. Not just 9x plus 14, Only central angles are the same, okay? Now, if it comes out that I did a lot with the inscribed angles. However, because some on your worksheet are like this, if it came off on the center and this was 9x plus 14, then that would be correct. This would be 9x plus 14. What's the difference between this picture, which is ugly, and this picture over here? The center, correct. So if it's coming off the center, it's a central angle, which would be equal to the arc. This is an inscribed angle, which you'd have to double it to equal the arc measure, correct? So then I would have 7x minus 8 plus 13x minus 2 plus 2 times 9x is 18x plus 28 equals 360. You'd have to combine your like terms. So that would be what? 38x? Because this is 20 plus 18 is 38x. And then you'd have a minus 10, but a plus 28. So that would be a plus 18 equals 360. And you can work that part out. Because, right? What did you get? X equals 9? Is that what you said? Okay. And if I needed a certain arc, if it asked it to you, you just substitute in, right? And one more, and then I'll hand out your work. If you do need a break, make it short because our class ends at 11. And only mamas can leave at 10:50. Obed and Peter and Samuel, they are not mamas. Only the mamas who have babies in the YLCC can leave at 10:50. Okay. So what am I going to do here? Okay, from here to here, right? Ah, this here would have an overlap because this is going to be, how did it, some of these are a little confusing. So let me look. What about from here to here? Oh, that's easy. Okay, so from here to here is this whole thing, right? It cuts from here to here. What's 112 times 2? 2, 2, 4. Do you see that it's overlapping with the like here's 150, but then the whole thing is here. So I can find QP separately. Yes, this would be 74 degrees. Okay. Okay, so now is there a way to find so this, okay. So now I know that this whole thing here is 130. How did I get one? Am I right? Yeah, 130. How do I know from here to here is 130? Yeah, I just timed this by 2. So now I can set this up. 8x minus 8 plus 74 has to equal 130. And those are the ones that get a little trickier because they have the overlaps. So 8x plus 66 has to equal 130. Subtract 66. 8x equals 64. What would x equal? Yeah, x equals 8. So that one's a little trickier. because you had to think about overlaps and find it. So it was like 3 steps. Okay, so let me go ahead and give you your papers to practice. Okay, I heard. Did everybody hear what I heard yesterday? I heard that we have some people in this class who are thinking about becoming mechanics. Yeah. Did we hear that plumbers make some good money yesterday? So I have a worksheet of different applications of these circle problems for different areas. I only have the odd answers, by the way. So just, I can get you the even answers if I do them by hand. But I thought these would be interesting for those who are going in the trades. Because I got this out of my son's trade book that he took in college when he was getting his associate's. And I think you're done with my protractors and compasses. So we can go ahead and collect those and put those away. Do you think when I gave you word problems, I tried throwing those on the test? How about the odds? Because the odds, I have the answers on the odds. Do the odds so you can check your answers. But I probably will throw those on the test. Can I get your compass? Odds, just the odds. Look at it. What's that got on my son's grade book from my test? Look at it.
Teacher, they are blaming on us. It's because we want to be mechanic. You are giving us, making us.
Guess what? I already had that as my lessons. I've always given them out every term.
Good. You give it every term.
I give it every term. Good. Thank you. So on the word problems, you all know what odds mean, right? The odd problems. Ones end in 1, 2, or 1, 3, 5. Because those are the ones you have the answers on. But there is geometry in the healthcare field. Oh yeah, you have geometry in the healthcare field. Okay, so I have a picture, and the one thing they asked me to do is about rotation. So they check your rotation. Medical or dentistry, a lot of pictures are taken with the x-ray. They do a lot of rotations and things like that just to get all those pictures. Wow. That's great. You will see. Probably not in the same form, but having this as a background makes it a lot Usually they have such studies, what they have them behind little, have you gotten an ultrasound or anything? Yeah, usually, well, x-ray, they put them, like they walk behind, and it's all sheet. And then the others are just. Another technology is one that's put like the probes on the head to do this, or they check for the heart rhythms and stuff like that. They can take this into the nurses. Good morning, how are you?
Dia,
What?
dia,
No, because you have a test to make up.
no, it's actually
Are you ready for your makeup class? We need to have a class where
Tôi luôn cày ngón đi cày 40 ngày.
I gave you yesterday. I gave you the notes for the meeting.
Luôn có mình.
And I sent out the video. So you're good? You just need a place to work? You have all of that? Is that what you're asking? I think I gave you all last week's work. What are they doing? In class. I only have you for 5, 10, 15, 20, 25 more minutes. It's for 25 minutes. Okay. So, do you want, I'm a little, because I could have swore I gave you all the work. Okay, I gave you all work. I could give you today's work too if you're not going to be here. I hope you're here. This will be today's work. So this is the do now. You can practice doing this. We're going to be going over. That's everything up to this point. And then this is going to be new.